Hello, this is Rick Powers at Western Technical College, Basic Statistics. Lesson 18, Poisson distribution. Review. Binomial probability is based on measuring the number of successes, x, out of a set of observations, n, when we know the probability of an individual success, p. Examples include the number of coins that would be heads, the number of students that would respond yes when asked if they like soccer. However, there are situations where binomial probability does not describe the conditions of what will occur. Examples: how many defects in a length of wire, how many hurricanes in a season, how many customers in an 8-hour day. For these examples, we need to use the Poisson distribution. For these situations, there is no limit on the possible number of events. That is, x can go from 0 to infinity. However, there is a limited interval where an event can occur. Many times these are limited in either space or time. We also assume that the occurrence of an event does not affect the occurrence of another event. In addition, we must be given an expected average number of occurrences per interval. Example: we could have an average of 10 customers within an 8-hour period. Of course, in real life, there are many factors that affect customer traffic, but we will assume for the mathematics that this is a generally true situation. So here's the formula for Poisson. Probability of x is equal to mu to the x power divided by x factorial multiplied by e to the negative mu. It is relatively complicated, but we have the technology to take care of the calculations. Consider then this graph showing probabilities for the number of customers for each hour of business if the average number per hour is 10 divided by 8, which is equal to 1.125. Note that we would be surprised to have 4 or more, but 3 might happen. Note also we would often have 0 or 1 in each hour, and we should definitely plan to have 2 or maybe 3. We can't have 1.125 customers, but the long-term average will be 1.125 for each hour. Here's a bit of a strange question. If we have 10 customers in 8 hours, what are the chances of having someone coming in the next 5 minutes? It's 10%, so in statistics terms, unlikely, but possible. Take a look at the results when we consider the entire 8-hour day with a mean of 10. The distribution becomes nearly bell-shaped. It turns out that the standard deviation of the Poisson distribution is the square root of the mean. I will leave it to you to show that the empirical rule is a good fit for this situation. So even though our mean is 10, we should expect anywhere from 4 to 16 customers per day if the Poisson process is a correct estimation. But the 4, the 5, the 15, the 16, they're still pretty low. Important, we should not assume that a distribution follows a Poisson distribution or a normal distribution or anything else, unless there are good reasons to do so. These can be helpful ways to analyze data, but experience is usually needed in order to make good decisions. End of lesson 18.